Alright. Hey, my name is Daryl Glover. Work for Nashville Fire Department. Been a fireman for about 3.5 years or so, maybe 4, right around there. Today we're going to be talking about fire hose, or the construction of fire hose, and how to perform a self-locking donut roll. The objectives today are to gain knowledge of a hose and the uses of each type of hose. We're going to learn about couplings, the purpose of them. We're going to also learn how to roll a self-locking donut roll. Hose construction. Fire hose is constructed of inner waterproof liner and 1 or 2 layers on the outside. The outer layers can be a double jacketed hose or a rubber jacket hose. And we'll discuss the difference here. The outer layers provide the strength to withstand high pressure that's exerted by the water inside the hose. Strength is provided by the woven mesh. The woven mesh is made up of like synthetic nylon material. It's woven super tight that it can resist a lot of pressure and a lot of abuse. These fibers that the hose are woven with are resistant to high temperatures. So when you're in a house and apartment, whatever, that's on fire, it can resist the burns, the high temperatures, mildew for afterwards. They're coated with a certain chemicals and stuff when they're made to help resist with the mildew. Can also withstand mechanical abrasions, dragging through a fire, glass, coming off the truck, dragging on concrete, just anything you could think of that could damage it, it's supposed to withstand it to a certain extent. Double jacketed hose are made up of 2 layers. Your outer layer is just going to be the basic protection of the elements that it's put through. The inner layer is what kind of helps hold the pressure from busting with the water pressure that you have in the hose. Like I was just saying, the outer layer of the double jacketed hose they're treated to resist water and provide added protection. Like if you're at a fire, you get car fires, especially, running through gas, through diesel. It's got to be clean, but the protection that it has on it helps it to be able to be clean, and you don't have to put it out of service. You just have to get it cleaned properly. Like I was saying, these fibers, they can resist, abrasions, cutting, hot embers, and it just helps to keep the inner layers to where you can still flow water through them. Double jacketed hoses, where you're going to use these hoses for your interior attacks on fires, your supply lines, anything that's going to take a lot of beating. You're going to be pulling these hoses through houses, through glass, over coals, anywhere you can think of, over concrete. And that's what these hoses are designed to do, is to be able to withstand the pressures of just what our job requires. And with the supply lines, they're the double jacketed too, just because of the amount of pressure that a hydrant puts on them, and then also the attack lines through the engines pumping them. We also, the other one, it's like you don't have just all double jacketed hose. Some are single jacket, but they're a tough rubber that's also called a booster line. That it's everything's woven together. You know, they're small. They're usually, I guess, maybe around an inch or so big. But they also have to withstand the pressure. But you're gonna be able to still use these hoses, and they're tough. They just can't take the heat and the abuse of what you would use for a house fire, apartment fires, anything of that sort. Like the material is strong. It's just like I said, the fibers are together. You would use these hoses a lot with your trash fires, dumpster fires. It's a lot easier to pull a booster line off of an engine to use than it is to pull a 50-foot section 1 3/4 when you just have a dumpster fire. Small wildland fires, you know, just like little brush fires that people's fires just kind of get away from in their backyard. Also, when you've been through the fire at a house, at a apartment, or anything that a booster hose can reach, you're gonna use these to extinguish hot spots, because it's just a lot easier to carry around. You can maneuver it better, and if it's feasible for it to get to the house, it's a lot easier to use than pulling around the 1 3/4, just with the weight and how wore out you are. The inner part of the hose is what prevents the water from leaking. It's a smooth, like rubbery type inside the hose that keeps the water in. That outer jacket just kind of helps reinforce that. But it provides a smooth surface on the inside, so that the water is going to flow. You're not going to have any friction loss. You're going to get adequate amount of water that you need just from the inside being that smooth liner. Like I was just saying, without it being smooth on the inside, you would have excessive friction between the water moving through the hose. It's going to cut out your pressure. It's going to cut out the amount of water you're able to put on a fire. The inner layer it's a flexible material that can be flexed and folded without developing leaks. I guess you can kind of compare it to a hose pipe a little bit, except it's a more durable, harder rubber. But just how you can have a hose pipe that can kink up, and it's just like a bigger hose pipe is kind of what it is. But that inner layer in the double jacketed hose, it's actually bonded to the first layer of the double jacket, the one that kind of helps keep the hose from really busting is what it does. But like I was talking about earlier with the booster line, like the rubber hose, the inner layers and outer layers they're just together. It's just one solid piece. Also, with hose construction, every hose has couplings. You have like on your 1 3/4 hose that you would have, it's a double jacketed hose, but you're going to have a male and a female coupling. You're going to have male on one side, female on the other. There's two types of couplings. You got threaded and non-threaded. Most of your like supply line, your large diameter hoses, they're going to have the Stores type thing on them, coupling on them, so that it's not you're not really having to twist to hook up to your engine and spin. It's just a coupling that sticks in, twist and lock, and you're good to go. You don't have to worry about over threading it. But like I was saying, one end has the male, one end has the female. Male couplings have the threads on the outside, as the females have the threads on the inside. The female couplings also have a swivel on them with kind of like I guess you would kind of call them like little beveled ends almost, to where you can take and put a, hook them up together, the male and the female, to connect two hoses together, but you can also take a spanner wrench and tighten them up, if you have small leaks through them. So that swivel keeps the hose from twisting. While you're twisting it, you can just twist the coupling rather than the hose twisting all up and making a mess. When you are connecting hoses together with the threaded couplings, you need to always make sure that they're properly aligned. Because if you don't, you're gonna cross thread them. It's gonna leak. You're gonna lose water. It's gonna kind of cut into your friction loss too. So you always want to make sure that they're fully engaged. In all of the threaded couplings, the female part is going to have a rubber gasket in it, which really helps it get seated in there, kind of like a gasket you use for anything that runs fluids through it. It's gonna, once it gets seated in there and tightened up, that rubber piece kind of flattens out and it cuts all the cracks out, so you don't lose any water and you don't have any leakage. Couplings are used to connect individual hoses. They're also used to connect to the hydrants, to valves, the nozzles, any appliances. I mean, the coupling is what's going to get you longer lays. It's going to get you connected to your engine so that you can pump. All couplings are constructed either with rocker lugs or rocker pins, and that's what I was talking about earlier, kind of the little bevel parts. But that's what you use with the spanner wrench to tighten it up when you're connecting the hoses together, especially like 1 3/4 inches. Most all companies use like a standardized hose threads. That way that if something happens and you have to have mutual aid come in, you could use their line to connect with your lines. That's just kind of across the board. As long as they're the same size, or even they have reducers and adapters and stuff that you can add to them, or just to make things work. But most all threads are the same. These are a few just kind of important terms to know, test-wise, I guess you would say. PSI, it's just pounds per square inch, and this is how the pressure is measured through our hose. The higher the PSI, like if you're pulling 1 3/4 or a tack line, it's going to be a lot harder to control. But all size hoses are pumped at different PSIs. But the main thing to remember is it's just kind of what we use to measure our pressure. Friction loss is determined by the diameter of the hose, the volume traveling through the hose, and the distance that the hose is laid. But you can also have it just kind of what it is. I know there's an equation to figure out friction loss, but if you're pulling hose going upstairs, where you're going to lose pressure like that. So I mean, you just anything you think of a bend in the hose, and going from bigger to smaller. I mean, you're just losing. That's just what your friction loss is. Also, water hammer. I know that when you hook up to a hydrant, you're running water through the hose, but you don't want to ever open the hydrant just full blast. It's gonna come up. It's gonna slam into your pump and could possibly bust the seals out. And you don't want to ever do that. So you want to make sure you open and shut everything real slow. Make sure the water gets there, and then open stuff up full. we're going to talk about a few hose rolls. I think there's about 4 of them. You got a straight roll, which is just taking and rolling the hose up. Just start at one end, which usually is the female end. Start rolling the female end up. Wait. Is it female? Yeah. Start rolling the female end up so that the female's on the inside. But that's just kind of what that is. Then you got a single donut roll where both couplings are rolled together. You know, this can be connected and extended by one firefighter. You got a twin donut roll, which is a hose roll. It's primarily used to make a small compact roll that can be carried. And what our practical is going to be on today is our self-locking twin donut roll, which this is it's just like the twin donut roll, but it has its own carrying loop. We're going to go into some slides that kind of show where we go with that. So what you do to start a twin donut roll, you're going to throw your line out, lay it flat. You're going to bring one coupling over the other, so it almost makes an X over each other. You're going to go down back to where the other side where the couplings are not. You're going to take and you're going to kind of flake your line out, creating a loop, and then that's what that loop is going to eventually be, what you're carrying over your shoulder. But you make your loop there, and you always want to wear gloves while you're doing this. That's probably the only safety feature that you need while you're rolling this, doing this roll. But then you're going to bring that loop back towards the couplings to the point where the hose crosses, as you can see there. Then you want to roll. You want to just kind of flake them back over how he has it where it's crossed over. Then you want to just start rolling it, making sure that your hose stays tight together. And the tighter you get it, the more compact it's going to be, the easier it's going to be to carry. So on completion of getting to the end of the rolls, you want to position the couplings so that they're on top of the roll. You want to take and you want to pull one of the loops, make it a little smaller. You want to roll the other loop over the couplings, as you can see, and pass it through the smaller loop. And when you do that, it almost creates almost kind of like a lasso type thing, to where when you pull it tight, everything pulls tight, kind of like a little slip knot type deal. I do have a video, but I'm going to ask y'all a couple questions before we go to the video. How is pressure measured through our hose? How do we do that? PSI. Yeah, that's correct. And that'll be one of y'all's quiz questions that we take after we do our practical. But it'll be a multiple choice. And then, true or false, a booster line is used for small outdoor fires.
True.
Correct. All right. And I'm gonna let you guys watch a video of a candidate from another fire department, which is I'm not sure where it's from, but this is referenced just off of YouTube. Also use the Firefighter Skills 2nd edition, chapter 16 for my other stuff. Let's play this. And this should show you this young lady here will go through the steps of how she does the donut roll. Self-locking twin donut roll.
Evolution.
I'd like you to do a self-locking twin donut roll with this 1 3/4 inch.
She already has it laid out.
Yes, sir. I'm going to make sure it's racetrack first, and then I'm going to cross over the hoses.
Do you want to do the I'll do it. this area. He's gonna try to rob.
Got a little commentary in the background.
That crossover is about 4 feet away or so, 3-4 feet away.
And you take this, scoop it up.
Right there? What?
And then you make it so the straps are big enough for you. I use smaller straps. And you pull it up. Pull this up. Make sure these are together. And then roll it. Make sure these stay together.
Hey, walk over here, right?
Side out. Pull this through. Then you go first strap. Okay.
Perfect shoulder pad.
And that's it. We'll go out, do the practical, get you guys checked off on that. Do you have any questions?
No. Good job.